Good morning, everyone. Today, we are going to discuss about the next concept in this descriptive statistics, that is percentiles, quartiles, IQR, that is in interquartile range, and the five number summary. What is this five number summary? That is minimum, Q1, median, Q3, maximum. These five is nothing but the five number summary. Let us discuss how we are going to find out this minimum value, Q1, median, Q3, maximum in the given data set. Coming to the first concept, that is quartiles. There are three quartiles which split the data into four parts. Actually, why we have to split the data set? Is there any requirement? Do we need these quartiles? Yes, of course. When we are doing finding the statistics, suppose take a company as an example. So they'll have n number of employees, and if you divide the number of employees into some quartiles, they will come to know the first quartile may have come to know how the lesser number salaries of employees. Maybe the last quartile they will come to know higher number of salaries of a particular employees. Likewise, in a given data set, if we divide these quartiles, we'll come to know the statistics of the given organization or work. So the first quartile corresponds to the 25th percentile. That is the 25% of the data is called as the first quartile. The second quartile corresponds to the 50th percentile and is also known as the median. That is, in a given data set, the 50% of the data is known as a quartile, or also we can also call it as the median. The third quartile corresponds to the 75th percentile. That is 75% of data is nothing but the Q3. Let us see how we are going to find out this Q1, Q2, Q3 with an example. This is the given data set. Okay, and we are going from this given data set, we are going to identify the first, second, and third quartiles. So the solution, let us see the solution. The very first step, first let us, in the given data set, we'll find the median. That is, as it is in ascending order. Okay. So in this data set, once you check how many are there. So in this, the 13 is the median. Why? Because there are 5 data points to the right and left of this 13. So it is going to split the data as 50 and 50. That is the step 1. And coming to step 2, group the data. Group the data of the left one, left to the 13 and right of the median. That is, so 2, 6, 8, 9, 12 is one group of data and 18 to 49 is one group of data. And so we are going to repeat the process of step 1 for each group. That is, for first group, we will find out the median, and second group also we are going to find out the median. That is, in group 1, this 2, 6, 8, 9, 12, we know that 8 is the first quartile, because there are 2 data points on either side of 8 and 2 data points this left side. So it divides the first half of data in half. Okay. Then coming to the second group, we know that 22 is the third quartile because there are 2 data points on either side of 22. And thus it divides the second half of data. So finally, the answer is, for a given data set, for this given data set, 8 is the quartile 1, 13 is the quartile 2, and 22 is the quartile 3. See here, quartile 1 is 8, quartile 2 is 13, and quartile 3 is 22. This is how we are going to find out the quartiles for a given data set. And the next one more important one is IQR, that is interquartile range. So it is a resistant measure of spread. This means that unlike range, we already discussed in the last session, which is a maximum minus minimum. It is not easily influenced by the outliers. So what is this outliers? Is this important in a data set to find out outliers? Yes, of course. So in a given data set, there may be some range from 0 to some n number. Okay. We may come across outliers, either it may be below the data or above the data. So there is a need to find out the outliers in the given data set. That is how we are going to find this with the help of IQR. So IQR can be used to find the both upper and lower thresholds of the data set. Above and below which numbers are considered as the outliers. Okay. So upper threshold and lower threshold, and whatever the numbers are below this and above this are considered to be outliers. So how we are going to find out this lower threshold and upper threshold? Here is the formula. So we already know how to find out the Q1, that is minus 1.5, okay, and into IQR. And what is IQR? Q3 minus Q. That is lower threshold. And coming to the upper threshold, we already know how we are going to find out the quartile 3 plus 1.5 into IQR. Again, what is IQR? Q3 minus Q1. So in this way, we are going to find out the outlier in the given data. The same example, how we are going to find out the IQR and how we are going to find out the thresholds. The same example, find Q1 and Q3. We already found these values, that is Q1 equal to 8 and Q3 equal to 22. And then we are going to find out the IQR, that is Q3 minus Q1, that is 22 minus 8, it is 14. And then like the next one is to find out the thresholds. So Q1 minus 1.5 into IQR, that is Q1 is 8 minus 1.5 into 14, that is minus 13. And upper threshold is Q3 plus 1.5 into IQR, which is 22 plus 1.5 into 14, which is 43. So check in this data set. Is there any numbers below minus 13 and above 43? How many are there? Yes, we don't have the numbers below 13, but we have one number above 43, that is 49. So in this data set, so here we conclude that 49 is an outlier because it is beyond the upper threshold. So when we are using this for calculations, so we can remove 49 from this given data set, so that a machine learning algorithm can give you the accurate results. The next one, it's very important, that is box plot. A box plot is nothing but a single box. It is a single box which gives us a visual idea about 5 components in a data set. And it is also known as box and are whisker plots, or simply it is a box plot. We can also call it a whisker plot, simply a box plot. So it is useful for describing measures of central tendency and measures of dispersion. Hope you remember central tendencies, measures of central tendencies. It is nothing but the mean, median, and mode. What is measures of dispersion? It is nothing but the variance, range, standard deviation. Even this IQR also comes under this measures of dispersion. So it describes both these measures of central tendency and measures of dispersion. So the 5 components, what it is going to represent, box plot represents, that is minimum value, first quartile, that is Q1, we can also call it as 25th percentile, second quartile, which we also call as Q2 or 50th percentile, third quartile, Q3 or 75th percentile, and the last one is the maximum value. So these 5 components can be represented with the help of one thing that is known as the box plot. And see here, this is the representation of a box plot. You can see here, this is a Q1, this is Q3, and in between we call it as a Q2 or median. And this whole thing, this Q3 minus Q1 is called as the interquartile range. And the range of this minimum value, this Q1 minus, and between this Q1, we call it as the whiskers. And here also, the point from here to the maximum value, in between we call it as whiskers, and the values above this is called as outliers, and below this minimum values are also called as the outliers. So along with the 5 components, box plot gives outliers, that is points lying beyond the minimum and maximum values, as I told you, and interquartile range, that is Q3 minus Q1, it is middle 50% of the data, and whiskers. From minimum value to Q1 is the first 25% of data. From Q3 to maximum value is the last 25% of that data. That is called as the whiskers. And let us understand this box plot with an example. That is, we have a data set of runs scored by a batsman in his 12 matches. So we are going to arrange the data set in descending order. For that, we need to divide the data set into 4 equal parts. That is, we have to find out the 25th percentile, 50th percentile, and 75th percentile of the box plot. And percentile is the number below which a given percentage falls, or you can also apply the below formula to find out the percentile. So let us discuss the same example this with the help of a box plot.